Welcome to the Security Practice Series from the AI Mock Interviewer Question Bank. Security Part 1. This episode has 16 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. GCP Services. Compute Engine SSH Troubleshooting. You are not able to SSH into a Compute Engine instance. What could be the reasons, and how would you troubleshoot it? Here's a strong way to approach it. Common causes are a missing or misconfigured firewall rule allowing SSH, port 22, from your source IP, the instance lacking a public IP, or you not using IAP tunneling for private instances, an SSH key mismatch, metadata key not propagated or wrong key used, or the instance itself being unhealthy, boot disk full, OS level SSH daemon not running. Troubleshoot by checking firewall rules and the instance's serial console output for boot or SSH daemon errors, verifying the SSH key in project or instance metadata matches what you're using, and confirming network connectivity, VPC routes, private Google access if using IAP is correctly configured. Nice. Let's continue. Question 2. GCP Services. Compute Engine SSH Access. What do we get when we SSH into a Compute Engine instance? Here's a strong way to approach it. You get a standard Linux or Windows via RDP shell session on the VM with the permissions of the OS level user account associated with your SSH key or IAM-based OS login identity, giving you the same kind of access you'd have on any Linux server, the ability to run commands, inspect processes, view logs, and manage the instance's local file system and configuration. Great. Moving on. Question 3. GKE or Kubernetes. GKE workload identity. You have workloads running on GKE. How would you give only one pod access to cloud storage? Here's a strong way to approach it. Create a dedicated Kubernetes service account used only by that specific pod's deployment. Bind it via workload identity to a GCP service account granted only the specific cloud storage IAM role needed, e.g. object viewer on a specific bucket, not project-wide storage access, and ensure no other pods reference that Kubernetes service account. This way only the intended pod inherits the GCP permissions, while other pods in the cluster using the default or their own service accounts have no access to that bucket. Alright, next question. Question 4. Security or DevSecOps. Service account key security. You know about service account JSON keys. Even if someone has the JSON key, how can you prevent them from creating or accessing resources? Here's a strong way to approach it. The most effective prevention is not having long-lived JSON keys at all. Use workload identity or workload identity federation so there's no static key to steal in the first place. If keys must exist, minimize the blast radius by granting the service account only narrowly scoped, least privilege IAM roles. Set key expiration and rotate regularly. Use VPC service controls to restrict what the key can access even with valid credentials. And monitor audit logs for anomalous usage patterns, unusual location, unusual API calls, that would indicate a stolen key being used. Let's keep going. Question 5. Security or DevSecOps. GKE image verification. In GKE, anyone can deploy a Docker image. How would you ensure that only verified and signed images are deployed? Here's a strong way to approach it. Enable binary authorization on the cluster with a policy requiring every image to carry a valid attestation from your trusted CI or CD pipeline before it's allowed to run. So even someone with cluster deploy permissions can't run an arbitrary unverified image. The admission controller blocks it. Sign images with cosign as part of the CI build process, and configure the binary authorization policy to check that signature or attestation chain automatically at deploy time. On to the next one. Question 6. Networking. Hybrid connectivity. How do you connect an on-premises network to a GCP network? Here's a strong way to approach it. The main options are Cloud VPN, ISEC tunnels over the public internet, simplest to set up but with internet-dependent latency or bandwidth, dedicated interconnect, a direct physical connection to Google's network for high bandwidth and low latency, and partner interconnect, connecting through a supported service provider when a direct physical connection isn't practical. Choose based on required bandwidth. latency sensitivity, and budget. VPN for lower traffic or quick setup. Interconnect for production grade, high bandwidth hybrid connectivity. Good. Here's another one. Question 7. Security or DevSecOps. GCP security baseline. What additional security measures would you implement for the GCP environment? Here's a strong way to approach it. Beyond basic IAM hygiene, implement org policies restricting public IPs and enforcing OS login. Enable VPC service controls for sensitive data parameters. Turn on Security Command Center for continuous posture monitoring. Enforce binary authorization for container deployments. And ensure audit logging is enabled and retained for all projects. Layer in Cloud Armor for internet-facing services and regular access reviews using IAM Recommender to catch permission creep before it becomes a real exposure. Nice. Let's continue. Question 8. Observability. Cloud logging analysis. You have logs in cloud logging. How would you analyze them? Here's a strong way to approach it. Use Cloud Logging's query language, logging query language, to filter by severity, resource type, and specific fields, and build log-based metrics for patterns you want to track over time. Error rate by service, specific exception types. For deeper analysis, export logs to BigQuery and run SQL queries for aggregation and trend analysis that the logging UI doesn't support well, or route them to async feeding a dedicated analysis tool if the team needs more advanced search or visualization than Cloud Logging natively provides. Great. Moving on. Question 9. GCP services. GCP project architecture. Describe a GCP project architecture you have implemented. Here's a strong way to approach it. A typical architecture uses a folder hierarchy separating environments, prod or non-prod, and business units, with one project per workload or environment combination rather than shared projects mixing concerns. Networking centralized through a shared VPC host project, and org policies enforced at the folder level so every new project inherits consistent security guardrails automatically rather than requiring manual configuration each time. Alright, next question. Question 10. Networking. Shared VPC. Explain shared VPC and when you would use host and service projects. Here's a strong way to approach it. Shared VPC lets a host project own and manage the VPC network, subnets, firewall rules, routes while attached service projects deploy their resources, VMs, GKE clusters, into that shared network without owning networking configuration themselves. Use it when you want centralized network governance and consistent IP addressing or firewall policy across many teams' projects, while still giving each team project-level autonomy over their own resources and IAM. Let's keep going. Question 11. Networking. Hub and spoke architecture. Explain hub and spoke architecture in GCP. Here's a strong way to approach it. Hub and spoke centralizes shared services and connectivity in a hub VPC or project, with spoke VPCs, per team or environment connected to the hub via VPC peering or shared VPC, so spokes can reach shared resources, like a central NAT gateway, DNS, or security appliances, in the hub without needing direct peering to every other spoke, simplifying network topology and centralizing control over cross-cutting network concerns. On to the next one. Question 12. Networking. Hub project resources. How do you deploy shared resources in a hub project? Here's a strong way to approach it. Deploy resources that need to be centrally managed and consumed by multiple spokes, Cloud NAT, Cloud VPN or interconnect gateways, centralized DNS, or shared security appliances, in the hub project's VPC, then configure peering or shared VPC attachment from spoke projects so they can route to and use those shared resources without duplicating them per spoke, which both reduces cost and centralizes operational ownership. Good. Here's another one. Question 13. Networking. Cloud DNS. Explain Cloud DNS. Here's a strong way to approach it. Cloud DNS is GCP's managed, highly available DNS service supporting both public zones, resolvable from the internet and private zones, resolvable only within specified VPCs, letting you manage DNS records via the same IAM and Terraform tooling as the rest of your GCP infrastructure instead of a separate external DNS provider, with low latency global unicast resolution. Nice. Let's continue. Question 14. Networking. CloudNet. Explain CloudNet and the problem it solves. Here's a strong way to approach it. CloudNet provides outbound-only internet connectivity for VMs and GKE nodes that don't have public IP addresses, solving the problem of needing internet egress for package downloads, external API calls, without exposing those instances directly to inbound internet traffic, which is a core part of running a private by default network architecture. Great. Moving on. Question 15. Networking. VPN gateway. Explain VPN gateway and how it connects networks. Here's a strong way to approach it. A cloud VPN gateway establishes an encrypted ISEC tunnel between your GCP VPC and an on-premises or another cloud's network device, routing traffic over the public internet but encrypted end-to-end, which lets private resources on both sides communicate securely without provisioning a dedicated physical connection. Alright, next question. Question 16. Networking. Cloud Router. Explain Cloud Router and its role with dynamic routing and BGP. Here's a strong way to approach it. Cloud Router enables dynamic routing using BGP, automatically exchanging route information between your GCP VPC and a connected on-premises or partner network over VPN or interconnect, so route changes on either side propagate automatically rather than requiring manual static route updates. It's what makes hybrid connectivity resilient to topology changes without ongoing manual maintenance. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.